All right, folks, welcome to 6.3, part 3. So we're going to do a few more examples that kind of mix and match all the information that we've already learned. And we're going to start with question number 1. So suppose that sine alpha equals 4 over 5 and cosine beta equals negative 12 over 13, where alpha is in quadrant 1 and beta is in quadrant 2. Part A asks us to find the exact values of sine alpha plus beta and tangent of alpha plus beta. So we're going to start right here with part A. Now, if I wanted to find sine of alpha plus beta, I'd have to remember that that is equal to sine alpha cosine beta plus cosine alpha sine beta. Now, if I look at the information that they've given me, I have sine alpha, and I need it. And I have cosine beta, and I need that. But as of right now, I don't know what my cosine alpha and sine beta are, so I can't finish the problem. But what we can do is draw some right triangles to help us find that. So I know that alpha is in quadrant 1, so I'm going to draw a triangle like this, and this will be alpha. And I also know that sine is opposite over hypotenuse, and 4 is the opposite, and 5 is the hypotenuse. And if I use my Pythagorean theorem, I know that this missing side is 3, because I can do the square root of 5 squared minus 4 squared, and that will give me 3. Now I can draw a similar triangle for cosine of beta, but I know beta is in quadrant 2, so I'm going to make my triangle face the other way. And this will be beta, and I know cosine is adjacent over hypotenuse. And again, if I do my Pythagorean theorem, I'm going to find that that missing side is 5. And so from my diagram now, I actually have my cosine alpha and my sine beta. So let's move this down here. I've got sine alpha is 4 over 5. Cosine beta is negative 12 over 13. Plus cosine alpha is adjacent, or 3, over hypotenuse, times the sine of beta is opposite, or 5, over hypotenuse. And all of those, again, I found those values by going back to SOHCAHTOA. Okay, now let's multiply out our numbers. We'll get negative 48 over 65 plus 15 over 65, or negative 33 over 65. And so this is our sine alpha plus beta. Okay, now the other part of the question asks us to find tangent of alpha plus beta. And from my formula, I know that that is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Now I'm using the tangent one this time because I have right triangles and I know that tangent equals opposite over adjacent. It's pretty easy for me to find the numbers there. So tangent of alpha is going to be opposite 4 over adjacent 3. Plus tangent of beta is going to be opposite, which is 5, over adjacent, which is negative 12. Then I'm going to go ahead and divide it by 1 minus 4/3 times negative 5/12. And if I go ahead and want to add the fractions on the top, I might realize I need to change this to a common denominator of 12. And so I'll get 16 minus 5 all over 12 over 1 minus, I'm going to go ahead and do some canceling here, minus plus 5 over 9. And if I work that out a little bit more, I will get 11 over 12 over 14 over 9, which is the same as 11 over 12 times 9 over 14. And I'm going to go ahead and reduce again. I notice that 9 I can divide by 3 and 12 I can divide by 3 just to keep my numbers a little bit smaller. And I end up with a tangent of 33 over 56. Okay, so I've applied both formulas, and the thing that's different about these problems is I had to draw the right triangles to help me figure out the other sides. Now part B says find the quadrant containing alpha plus beta. Okay, so part B. Which quadrant is it in? Well, I know that my sine of alpha plus beta is positive, and I know that tangent of alpha plus beta is negative. And if I think about a quadrant where sine is positive and tangent is negative, then other way around. Ooh. My sine is negative, my tangent is positive. This is going to bring me to quadrant 3. Okay, let's try another problem. So if alpha and beta are third quadrant angles such that cosine of alpha equals negative 2/5 and cosine beta equals negative 3/5, find sine of alpha minus beta and find cosine of alpha minus beta. So this time I'm going to go ahead and start with my diagrams. Now I know it's in the third quadrant, so I'm going to draw my triangle like this. I'm going to call this one alpha. I know that alpha has a cosine of negative 2/5, so that's negative 2 adjacent, 5 for the hypotenuse. And when I use my Pythagorean identity or theorem to find the missing side, I'll find out that this side is square root of 21. And again, you can plug it into a squared plus b squared equals c squared. Just remember that c is always your hypotenuse. Now, I'm going to do the beta triangle in a different color just so we can see this better. But for the beta triangle, it's in the third quadrant, so I'm going to have it facing the same way. And it is adjacent, or negative 3 over 5. And this time when I use a squared plus b squared equals c squared, I end up with this side being negative 4. And this should be a negative 21 because it's pointing down. Okay, now we should have enough numbers to fill in our sine difference and our cosine difference formulas. So sine of alpha minus beta equals sine alpha, cosine beta minus cosine alpha, sine beta. And that, if I use my triangle, is going to be negative root 21 over 5 times negative 3 over 5 minus negative 2 over 5 times negative 4 over 5. It's a lot of negative signs here, so we really want to be careful. The first set of fractions will give me 3 radical 21 over 25, and the second set minus 8 over 25. And I can go ahead and combine those into one fraction, so I'll get 3 root 21 minus 8 over 25. I can leave it like that. All right, part B says find the cosine of alpha minus beta. So we're going to do cosine of alpha minus beta, write down that formula with a plus, sine alpha, sine beta, and just like before, we're going to go ahead and plug in the numbers that we have. So I get negative 2 over 5 times negative 3 over 5 plus negative root 21 over 5 times negative 4 over 5. And that will give me 6 over 25 plus 4 root 21 over 25. Or I can write it as 6 plus 4 root 21 over 25. Okay, so just another chance to practice writing out those if you have just the trig function and they want you to draw the triangle. Okay, so let's go on to the verify the identity here. Now this one is pretty straightforward. We're going to take the cosine sum formula, plug it in here. We're going to take the cosine difference formula, plug it in there, and simplify. So we've got cosine u cosine v minus sine u sine v. That's the first part. Plus cosine u cosine v plus sine u sine v, and we want that to equal 2 cosine u cosine v. And when you look at this is a minus and this is a plus, so those go away, and I end up with 2 of the same things. 2 cosine u cosine v equals 2 cosine u cosine v. Not too bad. All right, let's do one last verify the identity. And this one looks tougher, but it's only got a few extra steps, okay? So I'm going to go ahead and take this left-hand side and try and make it look like the right-hand side. And I'm going to do that by starting off with my reciprocal identities, or my quotient identities. So cotangent alpha is going to be cosine alpha over sine alpha. And cotangent beta is going to be cosine beta over sine beta. And I want that to equal this other side. Now, what I need to do here is create a common denominator. And so I'm going to multiply the first fraction by sine beta over sine beta. And I'm going to multiply the second fraction by sine alpha over sine alpha. And when I do that, I'll get 1 over sine beta cosine alpha minus cosine beta sine alpha all over my common denominator of sine alpha sine beta. All right, we're getting pretty close here. 1 over means I can take the reciprocal of the bottom, or sine alpha sine beta over sine beta cosine alpha minus cosine beta sine alpha. And one last step, I notice that this is my difference identity for sine. And so that's where I get the sine beta minus alpha. And now I've made the right-hand side and the left-hand side equivalent. All right, folks, as always, if you have any questions, you know where to find me. Let me know, and I'd be happy to help you out. Have a great day.